Hi there, everybody. So what we're doing, we're going to wait a couple of minutes just to allow people to find the event, to click on the invite, get themselves logged in. So thank you for waiting patiently. I'm loving the comments. Who wrote "there's no sound in space"? That was fantastic. I like that. I'm just having a quick look through the chat. So, and I'll answer some questions as we go. We will be recording these sessions. What we're going to do is polish them up a bit so that we can use them in our practice as we come back and look at them. So they will be made available probably in about a week's time after the first set of workshops, but we'll confirm those dates later. But yes, all the materials will be available. So we'll leave it a couple of, maybe 1 or 2 minutes. My name's Mark. I'm today's moderator. I work here at EUMETSAT. I'll formally introduce it all and explain to you what EUMETSAT is in a minute. But basically, we are Europe's weather satellite, in a way, club or organization. So we're the people who look after Europe's weather and climate satellites on behalf of all the weather services all around Europe. So we work with all the weather services, with partners in the European Space Agency, who are responsible for making sure there's a European industry that can build amazing instruments. So a really nice example of that. I don't know if you've seen the Aeolus instrument, which has just come to the end of its operational life, which was a test by the European Space Agency. It was a real commitment to, that was a long-term investment, time. But basically, it's a laser in space that looks at winds. Stunningly impressive instrument, and we're hoping to run the follow-on mission so that we can carry on that really essential data. So we work with the European Space Agency and others to really make sure the weather satellites appear. But we'll talk about the Copernicus stuff in a minute, which is where this webinar comes from. I'm just looking at my clock. It's 4 minutes past. So if it's okay, let's start. So welcome everybody to this series of data visualization workshops. My name is Mark Higgins. I am responsible here at EUMETSAT for what we call user training. So helping people to use the data that we provide. EUMETSAT, we are an international organization, a European one, so all of Europe's weather services make sure that we provide the weather and climate observations from space that they need to help the citizens of Europe and the world with weather warnings, understanding the Earth's climate, understanding how the climate is changing. Now, this workshop is part of our Copernicus activities, and Copernicus is a wider European initiative to do with wider elements of Earth observation. So for those of us who come from the perspective of looking at clouds, we get to discover atmospheric quality, we get to discover land and land use changes, we get to look at the marine environment. And so Copernicus really takes us much broader. And over the course of these workshops, what we're going to see, so we've got today, which we're going to focus on storytelling. And in future workshops or seminars, we've got air quality and wildfires, looking at the oceans and sea ice, climate and weather, climate extremes, and then wrapping up in mid-June with how to access and use the data from Copernicus and EUMETSAT. A couple of other housekeeping issues. So we will be recording these sessions, which means that if you ask a question in the Slido, that will be part of the recording. So just to check that you're comfortable with that. And we will, of course, make the recordings available. So the reason to record is so that we have these resources available. What we're going to do is edit them up a bit, so polish them up a bit before we release them. We will be using a tool called Slido to ask questions. So if you go to slido.com and the hashtag is EODataViz, let me just check I've got that right, because I don't want to get that wrong. Yes, EODataViz, Viz spelled with a Z. And we'll post that in the chat in a second if you missed it, so don't worry about that. And we're going to use that to ask questions, because we'll be a few hundred people, and you will be able to ask a question, but you'll also be able to upvote questions. So if other people ask questions that you're particularly interested in, we would love you to do that, because then we'll be able to work with the panelists and ask the questions that are most interesting to all of us. Let me just share today's agenda. so we can see what we're going to do today. So this is what we're going to look at today. So we'll start off with a small introduction from the more Earth observing side. So we look at some of the things that we've done or that people have done to do with visualizing Copernicus data and why we're having this workshop. So that's going to be from Hayley, a little bit Mark and Annamaria as well, just looking at what are we actually doing when we do data visualization. We'll have a little bit of question and answers and then a short break. And then we turn to the storytelling professionals. I'm really happy to be joined by 5 journalists today. So Kasha, Gary, Jonathan, Achim and Alexander, just to look at their perspective on telling Earth observing stories or telling the Earth's story using Earth observing data. And this is what today's session is really about. It's about how we tell stories about our home, about the place we live, using the Earth observing data that we have. So without further ado, Hayley, I turn over to you, please. So Hayley Everking, who's a colleague here, Hayley Everking, who's a colleague of mine here at EUMETSAT, who's our ocean marines expert, but is also somebody who I've learned a lot about storytelling from. And Hayley, over to you to say more about what you've done and what you've learned.
Thanks very much, Mark. Just going to try and share my screen. Okay, you should all be seeing my screen now. If you're not, please stop me and let me know. So, hi everybody. As Mark said, a very warm welcome to the first in this Earth Observation Data Visualization workshop series that we've organized along with all our various partners across the incredible European Earth observation ecosystem, particularly under the Copernicus program. I'm Hayley Everking. I am a marine applications expert here at EUMETSAT, and I really think it is sort of the visualization of Earth observation imagery that brought me into this career. Looking at the Earth from space is an incredibly beautiful and humbling experience, I think, for those of us who do it. And so I'm really pleased to see this workshop come to fruition and to hear all the different stories that we're going to hear over the coming 6 different workshops that we will host. But let's get started. So I wanted to start really by saying where we are today. And I think we're at a point in history where we as people are more connected than we ever have been before. Part of this is to do with the technology we have available to us, the platforms, the media that allows us to communicate with each other and tell and share stories. And one of the consequences of that is that we now have more people able to tell these stories than ever before. And I wanted to just show that really nicely in this slide. It was actually from a talk I gave a while ago on the use of social media and Earth observation storytelling. So hence you see all the social media platforms on the side there. Social media is not just the only way of telling stories, of course, but just gives you an idea of the diversity. But on the right-hand side of this slide here, you can see just the sheer breadth of people that are able to use these platforms now to share things about the planet through the medium of Earth observation. Everybody from organisations like ourselves, EUMETSAT, our users, people like the UK Met Office, our politicians, scientists, myself in the centre there, Mark you'll also hear from today, and beyond that as well, people outside of this sphere of science. So journalists, a familiar face there coming up later, I think, although you won't recognise him behind the mask perhaps, in Jonathan, but as well musicians, artists, and even everyday members of the public. And the last person who I'm very proud to feature in this little grid here is actually my grandmother, who is a very proud user of social media these days. So we're all more connected than we've ever been before, but we've also never been more connected to our planet. And I'm sure many of you are aware of things like the famous blue marble photograph that was taken by Apollo 17, often thought of as one of the first images of our Earth. In fact, it was one of the first images of our Earth. Wasn't the first one actually came from satellites. So very appropriate that we're having this conversation today using these incredible instruments that we're able to fly still now. But that image, the blue marble, was credited with starting the modern day environmental movement. And I think it just really shows, even in its most modern formation, as you can see on the screen here, that this perspective really can connect us incredibly well to our planet. So this is an image from a very recent time ago from our brand new satellite. This is EUMETSAT's MTG-I1. an image from our FCI instrument. So I encourage you to have a look at the beautiful new images that are coming from that mission and be inspired, as we have long been, by images of our planet. But MTGI-1 isn't the only satellite up there taking pictures of our planet or measuring it using different methods. We'll learn that it's not just pictures that we get from space. It would be impossible, I think, to talk about the modern era of Earth observation without talking about the European Commission's Copernicus programme, which really is the centre of the Earth observation universe for us at the moment. It's designed to monitor all these different parts of our planet that we can see from those big picture images we get: the land, ice, atmosphere, oceans, everything. And as well as that, it's also designed to provide this data to everybody on our planet for the benefit of us all. And how is this done? Well, it's a big, ambitious program, so it takes a lot of people to be involved. As I said, it's led by the European Commission. It's technically coordinated by our colleagues at the European Space Agency. And it's centered around a series of satellites known as the Sentinels. I'm hoping some of you might already be familiar with some of our eyes in the sky on the Sentinels. And these satellites are operated by the European Space Agency and by us at EUMETSAT. So we provide data from those satellites to you all. We also provide the data to a suite of Copernicus services, and these organizations are designed to bring this data together, add value to it, incorporate it into models, and turn it into more downstream products that are really useful to help people address different problems and different challenges that we face on our planet today. And here were just a few visualization examples I pulled out from example use cases from the Copernicus services. You're going to hear a lot more about these over the course of this workshop and the ones coming, but just to show the sheer diversity of things that we can look at and how the data is relevant from space. Everything from aquaculture to monitoring land use to forecasting fires to studying our climate. Really, we can see everything we need to know about our Earth from these incredible space-based instruments and approaches that we can use today. But we're not just going to tell stories about these programmatic kind of elements of Earth observation at the moment. There's also lots of stories being told with Earth observation on an individual basis. And I'm a scientist by training, so I wanted to start by just showing a couple of examples here of how important data visualization is for telling stories about science to other scientists, to people who need to know about scientifically relevant information, but also to the public. It's incredibly important as a scientist these days to be able to visualize your data well to tell the stories you need to share with others. And the same goes for education. Being able to show somebody what something looks like physically, allowing them to play and interact with data and visualize it using software is an incredibly powerful tool for modern education. Data can also be linked really well now to current events. Our satellites are flying all the time. The data can be down in some cases in matters of minutes, but in some cases hours and days as well. It's incredibly relevant at lots of different timescales. Perhaps no more so is this true than in the case of weather. You've seen the animation there in the center of this slide showing this is Tropical Cyclone Mocha from day before yesterday, I think it was. This is from one of our satellites, and weather, of course, is a very explicit example of how data from space can be relevant for telling stories about what's happening on the planet right now. But there's some other compelling examples here: fires, looking at heat waves using current trends in data visualization, such as climate stripes. We'll hear more about those, I'm sure, during the course of the workshop. We can also observe everything from oil spills to stuck ships. I don't know if anybody here followed the Ever Given when it was stuck in the Suez Canal, but you've got a very good view of it from some of the Sentinel satellites at the time. And we can also use it to visualize trends in data that are somewhat scary. And I particularly liked this example on the right-hand side there from Tom Laverne, turning what is quite a worrying picture into something appropriate for sharing in a scary time of Halloween. We can also use Earth observation data to connect with stories being told by members of the public on the ground, places where you might not think that data would be immediately relevant. And there were two really nice examples I wanted to share here from my own personal experience, where we were reached out to from a lady who works as an outdoor tour guide who'd noticed a particular change in the color of the ocean around where she was hiking, and it had turned bright white blue in color. Quite unusual for Scotland. Normally, it's much darker and a bit more miserable there. But she was wondering what was going on, whether something had been something bad had happened to the water, there was pollution or something. And actually we were able, from the satellite perspective, to help her to understand what was going on here. And it was actually a big bloom of a specific type of marine algae that turns the water this chalky white color. Harmless, but very fascinating and beautiful to see. On the right-hand side was another nice example of commenting on a weather phenomenon of dust deposition that was seen at actually a motorbike race. And you can see this really beautifully in the satellite imagery where this dust was being deposited over the racetrack at the time of the event. So Earth observation data, I would argue, has something to say about almost anything going on in the modern world today. And it's not just about images. Stories, I really believe, can be told in many forms, and I would encourage you all during the course of this workshop to share examples like this. And I always think it's really inspiring to see how Earth observation data and imagery inspires people to share physical interpretations of what it means to them, whether it's working with an orchestra, Lego, cake, Play-Doh, or in some cases crochet. We can really turn data into meaningful communication with many different art forms. So what's coming up in the rest of the workshop? Mark will tell you more about the different things that are coming up in the different sessions in a minute, but we will cover those different thematic environmental areas that I mentioned: weather, climate, atmosphere, land, oceans. You'll hear all about these different topics, and you'll hear about them from data experts, people that work with the data and at the organizations that produce it. You'll hear from scientists and you'll hear from journalists. You'll also hear from people who will help you to learn maybe how to get more hands-on with the data. And I just wanted to give a few pointers for those of you who might already be sort of, chomping at the bit to get working with some of this data if you're not already familiar with it. So one way you can have a look at some of the images that I've shared so far in this presentation is on our EUMETSAT view surface. So this is view.eumetsat.int. Here you can access visualizations of our satellite data, and you can save them and share them with others. This is just one example of a couple of different case studies that we brought together. We also have a variety of different case studies available on our website. You can visit eumetsat.in and find those. They combine visualizations of the data itself, often with pictures and storytelling of what impact this sort of phenomena that we're looking at has on the ground. And there's just one particular example here I'd like to show from my own work, where we were looking at what was a harmful algal bloom that caused a huge deoxygenation event off the coast of South Africa. And a lot of these examples now come with supporting material so that you can actually get hands-on with the data yourself. We have, for example, with this one, a Jupyter notebook, which would allow you to retrieve and visualize the imagery that was associated with this event in South Africa. So our data also contributes to the broader Copernicus ecosystem, and you can have a look at the data viewer of the Wekio platform to see it in action, alongside data from all across the program, much of which you'll hear more about in the coming workshop sessions. Alongside the viewer, we also have a range of notebooks there that will help you to work with the data in a more hands-on way if you really want to get technical and start manipulating the data yourself. And that's everything from me. Welcome to the workshop. I really look forward to hearing from everybody who will present, and also from the audience. Please do contribute. You will make this workshop what we hope it will be. And with that, I'll hand back to Mark to summarize what it is we want to achieve. Thank you very much.
Thank you, Hayley. Thank you so much. So what you saw, on Hayley's last slide, actually, that's just a beautiful place to be right now. I think what we're trying to do with this workshop, so Hayley showed you a lot of the stuff that she's done and what we've done. We're very much trying to learn from other people and get better, because we've become more and more aware as we get engaged with Earth observing visualization that there are so many beautiful ways of telling stories out there that we can improve, and we can improve how we do that. So one of the things we'll do during the course of this workshop is gather all of the good practice that we see and put it together in a bit of a guide, but we'll leave that guide open for us to edit as a whole community. So if you have ideas or inspiration or good practice, you will be able to contribute it in. What we'll do is we'll have a pre-edited one there, so we're able to react to something and grow it rather than start from a blank sheet of paper. So thank you very much indeed, Hayley. Now we turn over to the Copernicus Atmospheric Monitoring Service and Mark Parrington. Hi there, Mark. The other Mark. I'm usually the other Mark because he's really awesome. I think Mark, you're going to tell us about your journey within CAMS and visualization. And I won't steal too much of your thunder. Over to you, and thank you so much for joining us.
Okay, thanks, Max. So can I just confirm that you see my slides in full screen mode?
Yes, they are there.
Okay, great, thanks. Okay, so thanks to Mark and Hayley for the introduction and the opportunity to talk a little bit about what we do in terms of data visualization and communication based on data from the Copernicus Atmosphere Monitoring Service. And it's going to be very much focused on that, and it's maybe not going to go into the level of detail that Hayley showed, but this is also a bit of a prelude for a more detailed presentation on visualizing air quality and fire emissions, which will be in the next workshop next week. Okay, so I think best to start with a little bit of introduction. So Hayley already showed us about the Copernicus program and the satellite hardware, if you like, which is being launched and operated and in orbit, and also these data services. So the Copernicus Atmosphere Monitoring Service is one of these 6 data services, and the purpose is to take the observations coming from satellites and put them into a form that's more readily usable by non-expert users. So basically, there's many satellites, many different sensors, they all have their own characteristics. And what we do is take away the requirement of downloading, well, essentially terabytes of data from these different instruments, but we put them all into a consistent framework. So, and combined with a model, basically a weather forecast model, which has all the atmospheric chemistry and atmospheric composition. And that allows us to build this self-consistent state, which combines all this information from many different inputs to give us a very clear view of the atmosphere. And so we're taking a lot of different observations, combining it with our modeling to provide then various products in relation to air quality, fire emissions, greenhouse gases, global forecasts, reanalyses that cover the last 2 decades, various other tools. And then there's a lot of downstream users that take these information. And part of the requirement for our data visualization and communication is to show that this data exists, but also show the applications, to show what it can be used for and what it can tell us in terms of the state of the atmosphere when there is pollution events taking place. And that's what I intend to illustrate to you very briefly today. For full information on our service and also how to access the data and accessing the data, I point you to our website, which is given here, and you can find all the details there, including help and user support and everything. Okay, so just a little bit of background quickly to how we tell stories with CAMS data. So Copernicus Atmosphere Monitoring Service, or CAMS, so I'll refer to it as CAMS from now on. So as I said, we're utilizing Earth observation data from many satellites and sensors to provide information on global atmospheric composition. So essentially, the simple way of thinking about it is a weather forecast, but it's for atmospheric pollution and air quality. So everybody should be familiar with a weather forecast, but this is then just changed over to looking at the actual contaminants in the atmosphere. It reflects the weather patterns, of course, but there's this extra information that we can provide. And one of the key things that we do in our service in providing this information is we're doing this quality control and verification against independent measurements where and whenever we can. And this is including measurements taken from the ground, aircraft, balloons, and other satellites. And then in terms of the communication, the real challenge we have is distilling these complex data sets, which are representing very complex processes of atmospheric physics and chemistry to a wider audience. And so the task is to visualize air pollutants, which are typically invisible, although there are cases where you can see them from space. So one of the challenges we have is because many of these air pollutants are invisible, i.e. we can't see them with visible satellite imagery, is we need to make that link to be able to explain what the data shows. And here, just to kind of try and illustrate this, is some satellite imagery taken yesterday by NASA's Aqua Modus instrument, and this is showing the smoke plume from these fires in Western Canada. And the image on the right is showing the forecast of aerosol optical depth from CAMS, valid for the 16th of May at midnight UTC. And essentially, it's just to show that these two images are reflecting the same thing, or they're representing the same thing, but there's different ways of looking at them. We don't have this visible capacity that the satellites have in CAMS, but we do have then the pollutants, which should show the same picture as what visible imagery shows. So when it comes to our visualization communication, we're very much relying on things like social media for being able to engage with the general public and users and journalists to be able to relate CAMS products and data to real world events and environmental issues which are affecting the atmosphere and which are taking place at the time that we're monitoring them. So these are just 3 examples here. So on the left, my focus has been much more on air quality and wildfires for many years, but also we have information on things like the Antarctic ozone hole. So on the left-hand side here is a tweet from December last year, and the data sets that we have and the amount of time Earth observation data has been available is we have tools where we can produce 40 years of data, particularly in relation to the Antarctic ozone hole, and straight away give some context to a current event based on those previous decades. And then this information is quickly turned around to social media, but then also we have website articles, press releases, and other ways of using this visualization to then provide more information and more explanation on what the data shows, how things are changing, and then what the state of the atmosphere is. In the middle here is another example. This is from June of last year, so July of last year. These were the fires in Alaska and the far northwest of Canada, which resulted in smoke reaching into the Arctic region, and again found its way into a website article. And we also contribute to various reporting activities. So on the right-hand side, some images from the Copernicus Climate Change Services European State of the Climate Report, and just to show that we have this information it's not just for the current status of the atmosphere, but also for looking back over, say, the last year or the last decade to try and understand how a particular season or year has evolved in relation to the past. And then I added this slide here just to show the impact really of being able to provide these relatively simple visualizations of these complex data sets to then engage with, in this case, the media, but this also extends to the more general public and citizens of the world as well, if you like. So what I found has worked is this effective engagement really comes about by having a quick turnaround of providing information on fire emissions. For example, this is the case of fires in the Arctic during the summer of 2019. So the chart on the left is showing the media coverage, the number of articles and the level of interest that we were receiving through our press office in relation to putting out information on our website and on social media in relation to these fires, which was quite unusual and quite surprising at the time when they were occurring. And what we see is from the middle of July 2019 through to the end of July, this very clear increase in the amount of interest in these fires and the information that we're providing that ultimately ended up in the numbers are here below, 1,400 pieces of coverage worldwide. And the important thing was to show that we had real-time information, that we were able to see the context in relation to the previous 20 years or so, and to also show what the impacts of those were on the atmosphere. And indeed, we've seen over recent years a clear increase in the coverage and the interest in our data based on the visualizations that we've been working on and promoting and communicating. And this is my last slide really, but just to bring us back to what I showed in the first slide, what goes into our visualization, it's not just we're making pictures and this is to show and that it looks nice and everything. This is really based on active monitoring of forecasting and Earth observation products to be able to see when these kind of events are taking place and to be able to actively monitor them, update the information and communicate with a very quick turnaround. So like I said, this is the state of these fires in Canada over the last couple of weeks. On the left, we see a map showing the distribution of the fires, and in the middle, some charts which show how the daily total intensity has changed over the last 2 weeks for these 3 provinces of Canada, and also the total estimated emissions. And this is part of this chain of storytelling where we can go from a map of fire locations to their intensity, how much pollution they're putting into the atmosphere, and then on the right is an animation of the forecast, which shows the smoke plume being transported thousands of kilometers across North America and indeed across the North Atlantic and reaching Western Europe in the next 4 to 5 days. And what's telling here is we also have information on Saharan dust, for example, which is crossing the Mediterranean, reaching Italy and Greece. And this is part of this ongoing chain of dust events. So these products are really showing quite complex processes and different interacting processes in the atmosphere, because this is total aerosol optical depth, and this shows us all the aerosols in the atmosphere, but we're also able to break that down to understand which bits of it are from Saharan dust, which are bits of it from fires in different parts of the world. And the key advantage to this near real-time monitoring is this quick turnaround of the data, as I already explained, and this is very helpful in response to journalist questions. So from a personal anecdote point of view, what I've seen through social media and media interest in fire emissions, but also atmospheric pollution in recent years, has been this real increase in the number of people providing information, but also the number of questions which come from journalists and the general public. So being able to provide this information with a quick turnaround is effective for 2 sides, for showing this data exists, how it can be used, and also promoting interest and showing that there are pollution events occurring in different parts of the world, which don't always get a lot of coverage. And this is important because through the atmosphere, through atmospheric pollution, we are all connected to different continents and to each other. Just to finish off on, maybe while we have this connection to the media and general public through these channels, what I've also found is social media also allows for this on-the-fly scientific analysis. So very instantaneously, you can get expert information from scientists in other fields. So I've learned a lot about ecology and fire ecology and forest ecology through my own interest in how fire emissions affect atmospheric pollution. And that's all been made possible through interacting with those scientists in social media. But also that local information, the information of people who are actually there experiencing some of these events, to be able to link those information together and to tell a more complete story, not just science, but also human stories, I think is also essential. And this is something that we're always bearing in mind when we're working on visualization and communication. So that's my final slide. So thank you very much for your attention, and I'll happily take any questions when the time comes around.
Brilliant. Thank you so much, Mark. Yeah, and we'll be using Slido for the questions. I'll just drop the link back in the chat so that you can find it very easily. Thank you very much indeed, Mark. Our last speaker in this block, before we turn to a short Q&A session, is Annamaria Luongo from the Copernicus Support Office, who is the visualization lead. It's a pleasure to meet you.
Hello.
And I hand straight over to you, please, Annamaria.
So wait a sec, I have to share my screen.
So we see you in presentation mode at the moment.
Now, I believe, yes.
Full screen mode. Thank you very much.
So, thank you very much, and good morning, everyone. Good morning, good afternoon, good evening, everyone. So, it's my pleasure to be here, and probably this is the first time that you see me in a workshop, because usually I am behind the scene. My name is Annamaria Luongo, and I'm the database lead of the Copernicus Support Office. But I want to start my presentation presenting my personal story, because it's important to start with this information in this kind of workshop. So I have a background in Earth observation, but I studied in south of Italy in a very little laboratory in the University of Salerno. And in 2017, I met Earth observation in the real life. I mean, there was a big wildfire in Campania, in south of Italy, the Vesuvio wildfire. And I was in my laboratory, and I saw the wildfire from my window. And it was insane, because during my study related to Earth observation, I never seen anything related to my hometown. It was my first time. And I started publishing on Twitter, and now I reconnect to the experience of Mark and Hayley, the image of the plume of the wildfire. And after, I started to bombarding my social media with the image of the smoke plume in my area. And what was the result of this publication? It was that there was an acquisition of Copernicus Sentinel-2, and I published the image on my social media. And there were several discussions with my social media friends about what is this? And this was a big surprise for me, because no one was interested in my bubble, in what I was doing at the university. So I continued with my publication, and 5 days after the event, I published an image that combined the data of Copernicus EMS. EMS is the Emergency Management Service of Copernicus that was activated for the wildfire. And I combined this data with the local data of my region. And the result was that someone of the communication team of EMS contacted me and told me, "Who are you? What do you want to communicate with your images? And what is the result of this discussion?" The result was that the Copernicus Support Office, so the management of the Copernicus Support Office, asked me to move in Brussels. In 5 minutes, I told them yes, because my mission was to communicate with the people that cannot understand what is Earth observation, what is related to the news, and why Earth observation is so important in our daily life. So this is my personal story, and I hope that this can inspire you for the future. And now I can say that I'm the database lead of the Copernicus Support Office, and I'm involved also in several other projects related to science communication, data visualization in general. So, what is my most important task today? The most important daily task is the image of the day. The image of the day is my dream, I can say, because my objective is communicate with Copernicus data, all the news that you see around, and translate in very simple way the news that are relevant for your daily life, that can be related to the air pollution, wildfires, beautiful.
We may have lost the connection to Annamaria. What we will do is wait maybe 1 minute to see if she is able to reconnect. Otherwise, I do have a couple of questions for Hayley and Mark while we're waiting, if you're there, Hayley and Mark. So one of the questions that I see in the Slido straight away is about the workflow to do visualization. So Hayley, if I could ask you just really quickly, I know we'll be discussing this a little bit later as well. Workflow, what does it take to set up a workflow that really works?
Oh, that's the question, isn't it? I mean, I would say the central part for me has always been the access to the data. So making sure that I can quickly get what I need, making sure that I can quickly look at it. Even if that's not the final visualization that I'm going to use and produce, it's really good to be able to quickly go, can I see something? Or is there an image that corresponds to that data that's cloud free? So I'll use a certain tool for that. Then I'll download the data using my relatively routine download approaches. And then I have a batch of tools and or people who are better at using those tools than I am, who will go and make the visualizations for me. So I would say often as well, it's a bit of a iterative job with myself and other people. So that would be, that's what you're asking for.
Place to do that.
Sorry, repeat that, Mark.
Do you have a pipeline in place or kind of set up for that?
For certain tasks, you can have a pipeline quite easily. I think if there's something that's happening routinely, and I think Mark probably can speak better to this than I can. I mean, CAMS does this really spectacularly well. If there's certain phenomena that you know are going to happen seasonally, that you know, even if they're going to happen periodically, you can routinely bring that data in and visualize it in a consistent way as well, which I think really helps with storytelling, especially over the longer time frame where you've got to look at, you know, how often has this happened over a year? Do we want to look at multiple days in animation form? So yeah, for me, I tend to work much more events-based and episodically, but I know other people have different experiences.
Mark, would you like to comment on that? And I also have one other question for you, Mark, which is somebody's asked in the Slido, where do you get the data for using CAMS? So where can people get the CAMS data? And do you have a pipeline set up for doing your imagery?
Sorry, I did. So maybe the second question first. So I did see the question in Slido, and I did send the link to our Atmosphere data store, which is where all the CAMS data products are accessible from. And then maybe just to back up, what Hayley said. So it's the same. I guess it started 5-6 years ago when I really started doing this seriously. It was setting up the data stream to know what it was I was looking for, or trying to understand better, which was essentially trying to understand fire behavior or fire emissions in different parts of the world. So most of my career I've spent looking at fires from boreal forests, and mostly in North America, and how that affects the atmosphere. So I knew that very well. But then working on the global fire emissions, it was a requirement. I mean, I felt that I needed to understand better those fire emissions in different parts of the world. So it was about identify the data stream, work out what tools or what visualization I wanted to use that could turn around quite quickly and just then be processed on a daily or very routine basis. And then, at least for my work, it's seeing where there's things that don't look quite as you would expect them to, based on many years of data. So when I started, August 2015, I guess, was when I really started, and this was the El Nino year, big fires in Indonesia, and you could really see, and it really showed to me the power of having these tools in place, because straight away you could see how much more emissions there were from fires in Indonesia than there had been in the last, back to 2003 or which is the start of our data set.
So
And then it kind of goes from there. So it's, you know, you look at other, if you look at things often enough, you get an idea of how they kind of look, and then when things do change, you can see that. And essentially that's what I based everything on.
So there's another question in the slide actually. Is there a difference when you're visualizing a current event like the Alberta fires right now? And you mentioned the sort of, is the Indonesia case worse than it was previously? So when you're doing a more climatological perspective, so do those work differently when you're doing those kind of visualizations?
Kind of, but the thing is, you can take the perspective from the climatological background in near real time, in the near real time events as well. There's information not just from the climatological background, but from other products outside of CAMS also, which we try and fold into the storytelling. So I didn't really have much time to talk about that today, but I might have a slide on that in the next workshop. But I think really the key thing is just having that basis for knowing what you want to look for or what you hope to find.
And I guess we'll see more of that in both the marine one coming up and the atmosphere and fires one that you've got coming up as well. If it's okay, Hayley and Mark, would you mind sharing in the chat the links to the CAMS service and any links to sort of open resources that you're willing to share already, even though it's slightly prior to the later seminars? Because there's quite a few people asking for them in the Slido. The other one people are asking for the Slido, so we'll share the recordings, and we're also needing to work out how we're going to share the presentations. You will get an email about that at some point with links to the presentations that people are willing to share. Some of the speakers might not be so comfortable, many of them will be. We just also need to check that we've got the proper attributions on them before we send them out. What we will do, unfortunately, and I'm really disappointed, we've lost Annamaria. So if we get her back before the end of the session, we'll get her presentation back. What we will do, though, is take the short break right now. We'll take a little break for 5 minutes. So we'll be back at 5 to the hour, and we turn to the other side of the storytelling question. We move from the world that many of us are familiar with, so my world of the world of science, to the world of the journalist, which is going to feel slightly different, and I'm really interested to hear from their perspectives, because there's a ton of stuff I know we can learn from the journalistic world. So thank you all so far. Do carry on asking your questions in the Slido and introducing yourselves in the chat, because it's just lovely to see where everyone is. But we'll be back in 5 minutes at 5 to the hour, wherever we are. Thank you. See you in a moment. All right, welcome back, everybody. Welcome back, welcome back, welcome back. So what we realize is in these long webinars, it's quite helpful just to take a 5-minute break. So for everyone to give everyone a chance to breathe, get a cup of coffee, go to the bathroom, whatever. So we are back. So now we turn to the journalists, which I'm really, really grateful that we get to hear the journalistic perspective, because those of us involved in science, these are some of the people we try and communicate to, and it's kind of helpful to know their world so we can actually do a better job of helping them to then tell the stories in a wider community. So we start with Kasha Patel, who's the Deputy Weather Editor from the Washington Post. Kasha, welcome, and over to you, please.
Hello, everyone. Thank you so much for having me. It is my pleasure to talk about Earth observation from satellites. It's something that I've been working in for many years. Right now, I'm currently at the Washington Post. I work on our weather and climate team. And I would say the way that we operate now is it's very, very news driven, obviously. And I've worked with Mark Parrington for so many years asking about data, the satellite data, things to actually make models or recreations for, aerosol transport from Siberia to the United States. At the Washington Post, we do have a graphics department, and they can do more intense data visualizations. But for me as a journalist, and for very quick turnaround, satellite imagery provides really valuable opportunity to show the public something that they can remember because it's so visual. My skills are a little limited. I'm not a coder. So the EO browser that the Sentinel Hub has been very useful for me. Before I was at the Washington Post, I used to work at NASA. I used to work at NASA Earth Observatory, which has an image of the day. So I would often use, I'm very familiar with NASA imagery too, but I think one advantage that you have with some commercial places and places like Sentinel is the frequency of the events that are occurring. You know, as soon as a fire happens, there's so many passes, so many satellites, you can probably get something pretty quickly. One thing that I've kind of focused on a lot is glaciers and ice. That's been extremely, you know, a lot of people don't, as far as news goes, glaciers melting happens fairly slowly. But you'll see in some of the online examples, some of the melt is incredible of how much it happens over the course of just a few days, a few weeks, maybe even just like 1 month. So that kind of gives you more time to pick out, okay, which day shows the most changes. And then of course there's more beautiful, fun imagery like the tulips blooming in the Netherlands. I don't have an example of that, but that's usually on image of the day. So I can go ahead, let's share the screen, and I'll just go through a couple of examples. I don't want to overwhelm you because I know there's other journalists talking as well. We can go to the first slide, the next slide. Great. So this one was one that I did this year, and I kind of like to follow Antarctica and Greenland. Because there's so much happening there, and the glaciers there. I mean, when you see an Antarctic glacier completely lose its snow cover, I mean, that's very impressive. These kind of stories, I feel like I tend to tune in a little more to this side. Sometimes it's social media, sometimes it's just the scientists who are constantly looking at it and they ping me. So this is one that I wrote this year, where it's literally Antarctic glaciers are snow-free. We can go to the next slide, and this is just one example. I actually did 3 pairs of this. So this is from December 2022 to February of this year, 2023, and you can see that it's practically all gone. There's other ones where like the glacier just completely disappeared. And this actually happened not because of one single heat wave, but because of just extremely high temperatures sustained over multiple months. So that's why the time gap is a little larger as well. We can go to the next slide. This one was from last year. I think we all heard about this story, and it was on several images of the day as well. This is the epic melt in the Alps. We can go to the next slide. So this one was interesting because you could see so much change over such a short amount of time. This was June 10th, 2022, so much snow. We can go to the next slide. 8 days later, you see it's starting to get a little bit, the darker gray shows that the snow's melting. And then the next slide. So within about in about 1 month or so, it was completely gone. And this was because of a heat wave. This was a summer heat wave. It wasn't nearly as long as what we saw in Antarctica this year. The next slide. This one shows Greenland, and this one's a little unusual because this shows snow growth instead of glacier melting. So you can go to the next slide. This is September 5th. Again, this is over a very short amount of time. So the September 5th, and then go to the next one. And you can, so you can see how much snow that Storm Larry actually brought there. And then we can go to this last one that I have. So like I said, I used to work at NASA Earth Observatory, and while we used a lot of NASA data, we would use Sentinel data when we needed to fill in gaps. So here you have September 21st, September 23rd, 29th, and 30th. And this is interesting because September 29th is the Sentinel image. This is glacial flower, and the resolution on that is just incredible. Whereas you can see the other 3 our Landsat. And, we had to do it that way because of the frequency and, the fact that that Sentinel imagery, you can see the difference is just pretty incredible. So in my opinion, Sentinel, I like to use it to compare over time periods and also pairing it with other, if you're lucky enough to get the same vantage point, pairing it with other types of commercial satellite imagery, government satellite imagery, or whatever it might be. And like I said, our data visualization team at the Post does a fantastic job, and they can do a little more in-depth stuff. But for me as a journalist who might be on deadline, has to get something out within 24 hours or, just that same week, this provides a very helpful source for me just to grab something very quickly and put it out, especially if you know where to look in terms of the scientific events that are happening and try and find different things that people might be missing. So that's all that I have. If anyone has any questions, it looks like we'll be taking them a little bit later on. Thank you so much.
Wonderful. Thank you, Kasha. Thank you very much indeed. Next, we turn to Le Monde and Gary Dagorn from Le Monde, who's the data journalist there. Gary, do we have you? Just to check.
Yeah.
Excellent. There you are. Wonderful. Over to you, please.
Yeah, hello, folks. So I'm Gary Dagorn. I'm a journalist at Le Monde at Les Décodeurs. It's an online column that provide explainers explaining journalism, and we rely a lot on data journalism and a lot of visual journalism. So we try to explain the news by providing visual representation of it that may explain or have insights. So I was offered to present a way that I used Copernicus last year is with the floods in Pakistan. The 2022 floods in Pakistan was a very, very big event and was terrible for the Pakistani people. I will share my screen now. I think you kind of see it, right?
Do we see you in presentation mode just now?
Okay. Is it okay?
Yes, thank you.
Yeah, sure. So, yeah, just like I said, I wrote a piece last year on the floods in Pakistan. So just to sum up a bit, the floods in Pakistan last year caused 1,700 plus deaths, 15 billions of damage, of material damage, $15 billion of economic losses, which is huge. 33 million people fled or were affected by the floods. It represents nearly 1 million houses destroyed and 1.4 million houses seriously damaged. More than 2 million people were left homeless because between June and September, the country has experienced the most intense monsoon rains of its history. We never saw that before. And it was in some province like the Punjab province. It was between 500 and 600% of a normal average monsoon, which was the monsoon has been preceded by a serious drought, and very, very dry soil do not drink water well. So that was an aggravating factor. The story was so big, it was so spatially extended. The whole country was affected. It has to be told from space. So that's where I turned to Copernicus. I contacted the Copernicus Support Office. Initially, I just wanted to get satellite imagery before and after the floods, which we already do from time to time. I mean, the before-after paper. So that was the initial idea. But then they provided me also as well with satellite data of the floods extent from Sentinel-1. So Sentinel-2 is a very, very useful tool because it can offer up to 10-meter resolution images in the visible spectrum as well as the near-infrared spectrum, I guess, I think. Below these is 2 images of the town of Ahmad Ali Lar, which is in the middle of the Punjab province. It is very close to the Indus River that flows through the Pakistan and flows into the Arabian Sea. The left one was taken 11th of August. The second one on the 2nd of September. You can see the difference between those two. This was taken 3 weeks apart, and in the middle of August, the country was already well flooded. The flood, I mean, the rains began in June, so you can guess the extent of the damage that's been done. Another example that was provided by Copernicus is the town of Bakshu-Benar, same dates, 11th of August and then 2nd of September. That was pretty clear. So that's the visible image part. The second part was trying to build a map of the floods, to trying to visualize in just one map the floods extent. So I used Sentinel-1 data. Sentinel-1 is a very different satellite because it's a radar satellite. So its instrument can monitor a wide range of phenomena such as sea ice levels, oil spills, land use, floods, of course, landslide, volcanic activities. So it can be usable. It can be used in a variety of ways. And the product that we are interested in for the floods is called the global flood monitoring. The global flood monitoring actually is very useful for the floods. It's one of the best projects, I think, for detecting floods because it relies on Sentinel-1 images that are processed via 3 different detection algorithms, and it's available fairly rapidly within an 8-hour delay. So you can actually do a piece of paper actually fairly rapidly. And it's freely available. You need an account, but you can use it freely after that. So the GFM data can be visualized on a map. For example, for mine, I took the following steps. So the data presents itself as a shapefile, which you can easily work with QGIS using, for example, the natural earth data, which I use a lot. And then you can save it as an SVG file. Then I took it to Illustrator to customize it. And then I took the map to HTML myself in order to make it interactive. I don't work on the print version of Le Monde, I work on the web version, so we're trying to do web-friendly things. So that's where the only drawback, of course, itself is that the shapefiles can be really heavy to work with because, for example, the spatial extent of the floods were so large that the shapefile itself was really, really heavy. So you need to simplify this. There are a lot of tools that can help you with this task. And or you can work with Annamaria or Copernicus to try to simplify the shapefile, which I did. And the final result was this. So this is the map that I've been working on, and as you can see, it was really spectacular to just see the extent of the floods. What was really useful too is that on social media, a lot of people in comments were talking about 30% of the country was underwater, which actually was pretty much 10%. So the satellite data is not only useful for telling visual stories and really visual shocking stories, it can also be used to make analysis and trying to be more factual and more precise in your story. And I guess that's it.
Awesome. Thank you very much indeed, Gary. We'll gather questions in the Slido, so we'll get to hear you again in a moment. Thank you, Gary. Now we turn to Jonathan Amos from the BBC, who is the, I'm going to say Earth observing journalist, but you're wider than that, Jonathan.
Yeah, I am. I hope not too wide. Anyway, so we'll attempt the video share here. So that's going to be it. And then if I start my slide, hopefully you can see all of that. Yes.
Not yet.
Oh, hang on. Share.
Here
we go. There we go. That's got to be it. Yes.
Now we see you. Yes.
Now you see it. Fantastic. That's absolutely brilliant. Yeah. So thanks very much for inviting me today. I've jotted down a few notes, not just sort of my own kind of thoughts, but had a little chat with people in the office as well. So, you know, it's sort of collection BBC wide kind of thing, but just a sort of resume of who I am really. So I'm Jonathan Amos. I'm a senior science writer at the BBC. I've been doing it for far too long. I write on the earth sciences, space, astronomy. I like to say everything from the center of the earth all the way out to the edge of the observable universe. And I do that online, on the radio and on the television, although I try and avoid doing too much TV because I have a face for text. But anyway, we do our best. So obviously I do a lot of Earth observation. I'm a bit of a kid in the candy store when it comes to EO. I find it fascinating. And there's really been an explosion in the last few years, sort of 10 to 15 years, in terms of the amount of imagery that's available to use to tell stories with. And that's driven by a number of factors. That's about the number of satellites that are in orbit now. That's all part of the small satellite revolution. It's about open data policies, the likes of Copernicus Sentinel and Landsat before it, but also the business models of the commercial companies that are coming up. This is really quite important. About 10, 15 years ago, those companies were thinking, well, we can charge the media for using our imagery. And they pretty soon realized that the media didn't have money for that. And so they started offering the pictures for free with credit for brand awareness. They found that that was a suitable way of dealing with the matter. And of course, you've got companies now like Planet and Maxar, ISI, these companies you may know, who are very much about getting their pictures into the media and raising brand awareness, and having access to that imagery is enormously helpful. And they're very responsive as well. If I get a message across to people thinking about operating, writing in this area, make friends with these companies because you can get a lot out of them, and I do. One of the things I do is I write about Earth observation policy as well, to see where all this imagery is coming from. And it's gonna boom in the next few years. There's a lot of space here for people to occupy. I think Euroconsult reckon that there's going to be about 3,500 Earth observation satellites launched in the next decade. It's an amazing number, right? It's triple what has gone up in the past decade. And a lot of these are constellations as well. So you're going to get rapid repeat imagery of particular locations on Earth. And you'll know with optical imagery, that imagery that is, you know, akin to what you see with the eye, you can't see the ground if it's cloudy. Well, the more satellites that are up there passing over a single spot, the chances are you will get a clear view of the ground. So it's going to become a lot easier to do that kind of stuff. I like to work with new types of data set, novel sensors. The picture before was Sentinel-5P in the clean room at Airbus in Stevenage in the United Kingdom just before it launched. And these are the kinds of data sets that it returns. This is formaldehyde over India. I love this. Formaldehyde is a trace gas in the parts per billion that you get in the atmosphere, comes from vegetation, but also, through to human activities, pollution, fires. What I love about this is you can see clearly how the Himalayas bound the distribution of formaldehyde. It can't move north. And then you've got this hole in the signal as well in the northwest of the country, which is a result of the deserts in Rajasthan. So not too much in the way of vegetation in that location. But the thing about Earth observation is it's just great for telling stories. And if they're big stories, enormous stories, and they don't come bigger than the Tonga volcanic eruption that we had last year. I wrote so often about this event simply because it was so extraordinary. 10 cubic kilometers of rock shot straight up into the sky, 20,000 to 200,000 tons of water injected into space. And when something is that big, but it's also quite far away as well, getting across to your audience what it was all about, Earth observation is one of the best ways of doing that. And of course, you've got the classic before and after. It's a bit of a cliche of Earth observation, but it is one of the best ways to render the information in a way that people will understand. And Earth observation takes you to places that physically you just can't go, sometimes because it's dangerous. So this is another volcanic eruption, 2018. This is Anak Krakatau, Indonesia. The western flank of the volcano collapses, generates a tsunami that kills 400 people on local coasts. Well, if you look at the imagery here on the right-hand side, 24th of December, that volcano was still erupting. You couldn't go anywhere near this volcano. And yet radar satellites could see through the ash plume, and they could see that a large chunk of this volcano was missing. And that explained that disaster and why it had happened. This is, I think, one of the best examples of EO in the news in the past year or so. So this is the Bucha massacre in Ukraine. So the Russian troops, they murder civilians, prisoners, up to about 500. They just shoot them in the street. And the Russians say it wasn't them. It was the Ukrainians. It was a false flag. There were actors, Ukrainian actors lying on the ground, and then they drove a video camera past. And yet media organizations, New York Times, the BBC, were able to pull together the pictures, the videos, the stills, but also the EO data as well, to show conclusively what exactly happened at that location, and that it was a war crime. And hopefully somebody will pay for that in due course. If I've got some advice about how to use EO data, that I kind of two things I'd like to get across. One is the reader, the lay reader, viewer, sometimes needs a bit of help in understanding what it is that they're looking at. Okay, so that might mean labeling. Quite often it means a scale bar. Okay, right. Just actually being able to judge how big things are, how small things are. And this one, it doesn't matter quite so much because you've got a football stadium here. So you can kind of judge the scale of it, the city blocks and all the rest of it. But this is the Turkish earthquake. And what we're trying to convey is how many buildings have been damaged or destroyed. Now, remember, 80% of people consuming BBC News are doing so on a mobile phone. They're looking at a mobile phone screen. Will they be able to get what it is you're trying to convey to them on that screen? All right. So you might need to help them in some way to make sense of it. And in this case, we've got the buildings marked in purple and one or two locations actually labeled as well to help them navigate the image. Lean on experts is the other thing. I always say I'm not a particularly adept individual technically, but I know some people who are. Now this is the Turkish earthquake again. This is very powerful satellite data. This is satellite radar interferometry. So you take a before image and an after image, and you can see the difference in land movement, sometimes at millimetric levels. But in the case of the huge earthquakes at the beginning of the year, we're talking about movements of 3 meters or more towards and away from Sentinel-1 as it flew past Turkey. Now, we knew obviously that Sentinel-1 could do this. There should be 2 Sentinel-1s in the sky. There's only one at the moment because one of them broke down. We should get another one fairly shortly. But it was going to be about 3 or 4 days after the earthquakes that Sentinel-1 was going to be in the right part of the sky. And so we arranged to speak with the team at Leeds University in the UK on the Friday morning when the data came down from Sentinel-1, we had a discussion about how best to render the data. And then Friday afternoon, we posted this image. And you can see clearly here the massive movements in the ground from the two quakes that occurred within a couple of hours of each other on that dreadful morning. An appeal that EO data is not just visual imagery. It's not just that optical image, you know, what you see with your eye or akin to what you see with your eye. It's all sorts of EO data that can be visualized. So this is one of my most favorite ever maps. It's a map of the ocean floor. It's constructed from altimetry data. So this is microwaves pulsing the surface of the ocean, judging the gravity signal. So the shape of the ocean surface has a gravity reflection of what is the topography on the sea floor. And then you can make a map of all of the lumps and the bumps and the seamounts. And they did this back in 2014 with Cryosat and JSON-1. And I mean, this map is our best view, really, of what's down there. Only a quarter of the ocean floor has been mapped by ships at the surface or vehicles under the water. Only a quarter. So the other 3/4 comes from EO data like this. So it's quite extraordinary. Automatic ship identification, AIS, automatic identification system. Get it right, get the acronym right. So this is a ship. It's got a transponder on it, and there are satellites overhead, and they're tracing the movement of the ship. In this case, it's the RV Polar Stern from the Alfred Wegener Institute, and it's doing a circumnavigation of this enormous iceberg, A74, that broke off the Brunt ice shelf a little while back. And the reason that they were doing that was because they wanted to get in between the ice to see the sea floor, to see what was living down there. So the sediments there had been covered by ice for more than 50 years. Was anything living there? It was teeming with life. But we were able to follow the journey of the RV Polar Stern from this room. From this room, I could see what the Polar Stern was up to. And then we were conversing with the ship's crew via satellite radio. So an interesting story. If we're on the topic of icebergs, I think I'm kind of known as the BBC's iceberg correspondent, because I do chase them across the ocean. A68, this behemoth, the biggest iceberg in the world at the time. This is kind of when I knew Earth observation on social media really was a thing. We followed this beast for several months as it drifted across the South Atlantic towards South Georgia, the British overseas territory. Was it going to smash into the island and block the passage of penguins and seals trying to forage at sea, or would it sort of sweep past? Well, in the end, of course, it broke up and the penguins were safe. Any idea what this is? Any idea what this is? Have a look at it. It looks like a 4-year-old's art class, doesn't it? It's fantastic. It's this. So this is the Nord Stream leaks in the Baltic Sea, but it's imaged in the mid-wave infrared. So this is a new sensor that's going up in the next few weeks. So essentially, it's sensing heat energy, and it's going to produce some fascinating data sets. So this is something I'm going to follow. It's being flown by a company called Satellite View. They're going to have a constellation. And you'll be able to do all sorts of fascinating things with this. So you can make temperature profiles of the city. You can see which houses have got bad insulation. Local authorities might use this information to target grants to improve insulation in the housing stock. In the UK, we have terrible housing stock. We leak an awful lot of heat through our roofs. Intelligence as well. So on the left here, we've got an optical image of a power station. But if you look at the midwave infrared, and this is the actual sensor that's going to fly on the satellite, but it's been tested obviously in an aeroplane and then de-resolved to give you the kind of imagery that you'll get from space. Well, you can see that only 3 of the 4 turbines in that power station are actually working. at the moment. So you couldn't get that information just from the optical imagery, but from the heat sensor, you can. We've never had this kind of data at this resolution. It's about 3 to 4 meters. Obviously, the military, they like to see hot things, and they have that capability. But as a commercial sensor with data out there that we could use, we've never had access to that before. We've got to have a conversation about satellite radar. It's difficult to use, but on the other hand, it is amongst the most powerful of all of the EO data sets out there. It really is. But it's also one of the data sets that's hardest for the public to engage with, I think, and they really do need help. And you know, I'm no particular expert, has to be said. If you go across to Sentinel Hub, which we've had mention of before, you can obviously run scripts to highlight particular areas. So this is the town of Tewkesbury and the west of England. It's the confluence of two rivers here, the Avon and the Severn. It pretty much floods every single year. It's a nightmare for the people who live there. And you can see quite clearly from the way that the script has run on the Sentinel-1 radar image, the water sticks out. Radar's very good at seeing water. It's not just seeing through the cloud or seeing at night. You get an excellent image of water surfaces. We've got to find better ways of accessing this information, getting it out there in ways that people can use it. As a little bit of a joke, just to end this talk, I asked ChatGPT if it would run a script for me on the same image to highlight the water. This is what it came up with. So the language models, the large language models, are an aid. They're only going to get better, I'm sure. It's not bad, is it? I mean, interesting choice of colors, I have to say. But you can see clearly that the water is there surrounding the town of Tewkesbury. I hope it doesn't flood anytime soon. My mother lives very close to this. So I'll leave it there. So just some points to take away, really. Lean on experts. That's what I would say. Cultivate them. You're going to see and hear from some great people over the next few weeks, people that you ought to cultivate if you're thinking about writing more in this area, helping you. And that's not just, the public sphere. So not just the space agencies and the like, but the commercial companies as well, because they have some great help that you can access. They've got their own newsrooms, if you like, that are constantly wanting to work with journalists. Okay, they want to get their brand out there, but also enables you to tell stories as well. So I'll leave it at that.
Thank you very much indeed, Jonathan. Thank you. And we're gathering questions in the chat, so we'll get everyone together in a moment. Thank you, Jonathan. Now we turn to closer to home for me, to the Spiegel and Achim Tack and Alexander Epp, who are doing definitive screen sharing. Thank you. So over to you, please.
Thank you very much. That was awesome and super interesting already. So we'll start by sharing our own screen. All right, let's do this. All right, you should see everything and hear us quite nicely. Perfect. So my name is Alex. I'm working with the graphics department at Der Spiegel.
And it runs automatically. So and I'm Achim. I'm with the data journalism team here at Der Spiegel. And today we just wanted to give you a quick introduction on all things spatial that we do. It's not all Earth observatory stuff, but give you a broader perspective on what we do here. So first of all, and this is more for the scientists out there and less for the journalists attending. We just want to get across the range of topics that we cover as data journalists at Der Spiegel. Der Spiegel is quite large German news outlet, but we don't have a dedicated climate desk or Earth observatory team. So just to give you a quick impression, it's quite common that in the morning we work on stuff like algorithmic accounting or the energy crisis. In the afternoon we do something about mobility. And then we have the let's say climate topic or an Earth observatory topic. So it's all about the broad range, which by definition means we are no experts in the topic. And during the course of our presentation, we want to show you a little bit about, or tell you a little bit about how this affects our way of working with Earth observatory data.
Exactly. So our approach can be super simple. For instance, the satellite image of the week, which is basically a satellite image that caught the attention of our colleagues, and they basically write a story about it. So there's not much data visualization on our side. We just write a nice story about super impressive imagery. But of course, we also have to cover news events, and we also already talked about Maxa and Planet, the big suppliers. And also for us, it's very important to be in contact with them. For instance, when in Sudan the clashes erupted, we talked to our partners, and they supplied us with a very high resolution imagery. So because sometimes it's just super hard to be on the ground and to cover the stories. And unfortunately, Sentinel doesn't offer the resolution we sometimes need to see things clearly. But what it does offer is, for instance, Sentinel-1 radar data. We talked about it also a lot, which can be super useful when tracking ships or when tracking military movements, of course, because as we all know, if there's a cloud, we can't see anything, but radar can see through the cloud. So it's super helpful. And for us, it became more and more important to use it for OSINT and verification also, because, for instance, we had a story about Chinese detention camps, the Xinjiang police files, and it was a huge data leak. And inside this leak, there were thousands of pictures. And some of those pictures showed military and police officers outside the compound. And we didn't really know if those pictures were really shot outside this compound. So we looked for specific unique features and then compared it to very high resolution image data. And then we could verify that those pictures were indeed shot outside the compound. Sometimes the approach is also a bit more abstract. I'd say if we utilize NASA FIRMS data, which shows heat anomalies, you can also use this to see sometimes if there's fighting going on or warehouses exploding. It's just one piece of the puzzle. You can't always rely on this, but it can help you to narrow it down a bit. And then, of course, we have more complex storytelling and data journalism projects, and we take sometimes 2 weeks or a couple of weeks to work on them. And some of those we want to show you or talk about.
Yeah, this is just a quick example. Basically, it was story we had, I think it was last year, about the burned area of the data taken from the European Forest Fire Information System, EFIS. Some NASA data was included as well. And this would be some sort of medium project, I would say, not a one-day project, but something that's been done quite quickly. Basically, this is a reaction to a current news event. For example, we see a lot of fires there, and we just want to give, let's say, a little laid-back overview of basically how bad is it this year compared to other years. So this is quite a typical, I would say, medium-scale project that we do.
Yes. Another project that some colleagues of ours did a couple of weeks ago was actually super interesting. Because they utilized NASA's Global Modeling Assimilation Office database, and they took the still frames, and what they did afterwards was creating a clip, and they visualized it with Svelte and 3JS. So they created this very nice sphere, which is very performant if you use it in your smartphone, for instance. And we already talked about that we always have to keep the reader in mind, that they're probably on the move and they use their very tiny phones, and you have to try to put all this very interesting data into nice visualizations that can be digested on a small screen, which is always kind of a challenge.
Yeah, the next example actually is not about Earth observation, but it's a spatial example as well. And I just want, from a journalistic perspective, I think sometimes we don't have to do, let's say, the large overview effect or use the overview effect of having satellite data. This was basically a little story we did about wind farm legislation in Germany, and it was some sort of spatial what-if scenario, if you want to say so. We just simulated how many German wind farms wouldn't have been allowed if the very strict Bavarian conservative wind farm legislation would have been taken and adopted all in Germany. So this was basically the idea of creating this spatial what-if scenario where everybody can see, okay, would this wind farm still be allowed if the Bavarians had their voice here? And we actually used PostGIS here, Python pandas, and did the visualization in Mapbox. This is more like, with this example, we want to show you that it's not all about the images or the satellite images, but sometimes this spatial reporting can be interesting as well for us.
Yes, and another example we would like to talk about is, and we already talked about the earthquake that happened in Turkey and Syria. And for us as journalists, it's always very complicated because we don't have much time to work on the stories, but we would like to do all the fancy stuff. And in this case, it was really nice because Planet, a partner of ours, approached us and they told us, okay, we have this awesome AI damage assessment, and that is something that we really like, but we don't have the people doing this, and of course it's super complex. So they said, okay, we teamed up with Microsoft and we can provide us with the data. And they also gave us a study and the most important results in brief, and also the link to the whole study so that we could dive deep into this and get more background information and a short description of the methodology, which is also important for us to validate if the data is the right one for us. And also a nice geo package, because this is also very important. We have to work with this data easily. And in this case, we could just throw it into QGIS and then see what the damage assessment was. And then they also provided us with available high resolution, very high resolution satellite imagery. We could then merge it, which was kind of nice, actually.
Achim, just to check, your slide may not have moved on to that example.
Oh, okay.
To the last one or to none at all?
So we're still on Spiegel. We may not have seen the last two.
Oh, so we talked a lot and you didn't see anything, which is kind of disappointing. Okay, let's try something else, maybe.
Give me a second.
Okay, we'll stop sharing.
We'll just reshare for a second. And why didn't you just tell us earlier?
Okay, maybe.
I thought you had a summary. Sorry about that.
Oh, sorry. No.
Does this work out for you guys?
Scroll down and we can see examples better.
Oh, too bad.
You just have to cut it together afterwards. Oh, we're so sorry for that. We're talking and showing kind of nice examples.
Okay. And the next one?
And the next one. And also the other one.
Yep.
Much nicer like this, actually. All right. And
that's the one.
Okay, okay, sorry about that. So that's the one I was talking about in the last sentences. It was about how we merged the QGIS data, like the damage assessment, with a high resolution, very high resolution satellite imagery, which is super helpful, which is just an example of how nice it is if we work together with scientists who have this enormous expertise, which we can't have. And if they know how to deliver the data and how to work with us, it's super efficient and it's super helpful, and the results can be amazing, even though you're in a new situation where you don't have much time as a journalist. And so that's why, it's super important to think about how to deliver the data.
So our last example for today, I hope you can see it now.
Yes.
Is something, and I read it in the question chat earlier about I think it was someone from Ghana. Greetings, asking about how you can visualize Earth observation data with for people on low bandwidth, for example. And one thing that we thought about this as well, because sometimes it boils down to simple numbers, to simple, very little visualizations, little pictures. That just give you an overview of about the current state of the climate. And one thing that we did at the Spiegel was actually pull data from quite various data sources, and yeah, creating very little images there, very little icons, if you want to say so, and they are animated and presented as some sort of dashboard on the Spiegel website, and they are created every day new via Python scripts. So they show complex data sets, but they are boiled down to very simple numbers, very simple trends, and then presented in a nice, very little way or reduced way.
All right, which brings us to challenges in using EO data. Like we tried to explain, we often have to work with shifting topics and domains on a daily basis, so we have to be very flexible and also balancing multiple stories and data sources. So we don't have much time. We have to quickly grasp complex data and understand how to make it work for stories. So in most cases, we don't have the time to dive deep into it, which is kind of depressing sometimes, but yeah, we have to work with that.
So rounding it all up, the organizers of this event asked us if we had some sort of wish list for the scientists, like in a perfect world, what can you provide the journalists? And we just came up with a few ideas. First of all, I think it always is helpful to have the short description of what the dataset says, why it is important for a story. And then, as we said earlier, I think it's super helpful to get the data in let's say netcdf files or let's say more complex files. But it's also important, and I would say for the rest of us who are not able to work with more complex data, to boil it down to really usable CSV files, GeoTIFF files, as you said earlier, shape files, even GeoPackages, stuff that you can use with open source software and stuff that you can visualize with little visualization tools or easy to access visualization tools, for example, like Data Wrapper, stuff that you can really throw into a simple tool and then create a compelling presentation or visualization in your own style. Style meaning the corporate identity of the news outlet. That's super helpful. It's always also helpful to have clear descriptions, and the descriptions should be acronym free-ish, I would say, because lots of times we get the README file, let's say from an open data portal, and for us non-scientists, let's put it this way: they are written for scientists and not for journalists. And as I said earlier, we switch between topics so much that it's just not possible to understand them properly. And going off on this, I think it's helpful for you scientists to provide graphs and maps and provide the data right next to them, so we know what the map should look like and be then able to reproduce them. That's basically, that would be gold standard. If some sort of if you do a press release, for example, you have this line chart there and have the CSV attached. That would be super helpful. And last thing, I think it would be helpful to have access to those domain-specific experts for verification, and to get really to the gist of it, to understand whether we understood your data right, because this is basically the most important thing. We need to be sure that everything that we present is correct, and we need easy ways of let's say check back with you guys, with the scientists, to understand if we did it right, if we got the information right. Yeah, and basically that's everything from us.
Right. You stop sharing.
Awesome, thank you very much indeed. What I will do is share my screen, where I've got a massive great list of questions, and we'll pass them on to all the journalistic community. Gosh, we've got a big old list. This is great. So, I mean, actually, to the other journalists, so at the end there, Achim and Alex, you presented a little list of a wish list or a love letter to the science community of things you would like to receive. Would any of the other journalists like to add to that?
Well, I would just say the media don't have a lot of time to process raw data, so they like the imagery presented to them in a processed form, but as our fellows said there, we need to do some pre-publication manipulation of the image, which broadly comes down to what they described. So it may involve putting city labels on where the city is. It may involve highlighting, colorizing something to make it clear what we're actually looking at, a scale bar, that kind of thing. But the important thing to remember here is that when scaling images for publication, you do it before you put any text on. So one of the, because when you crop something and then you know, if it's got writing on it and you crop an image with writing, the writing goes all funny. Okay, so you crop and then you put text on top of it. And so we need a bold image. It's nice to have an image that you've annotated, okay, so that we know what we're looking at. I can share it with a designer and say, look, you know, that's a good label to have. Now, can you do it for me? I'm talking about my data visualizer in the office. Can you now do it for me at the right font that we use, that will render on a mobile phone, that somebody on a bus will be able to see that easily when they open their smartphone. So yeah, but we will come asking for this, right? I guess the thing is not to be surprised when we come asking for this kind of help.
It's helpful to know who to ask, but you can get there quickly.
Yeah.
Gary, do you want to add to that at all? You are muted if you're answering, Gary. Otherwise, you don't have to answer. Oh, okay. And are there any other, so we just go through some of these questions now. So what are some of the bigger blockers that are stopping you from using more? So you've mentioned some in your presentations. Is there anything else you want to highlight? I guess if we start with Achim and Alexander, anything you'd like to bring out? Are there any other blockers that stop you using more?
I mean,
go on, Sargo.
Okay. I just say satellite imagery, of course, it's true that you can be supplied without any charge, but sometimes it's still super expensive to use it, especially if you have larger areas that you want to cover. So that might be a problem. We have some subscriptions with Maxar and stuff, but it's super expensive. And I mean, for the smaller outlets, it's even more expensive. So that might be a big problem, actually. Price still. And also where to get the imagery, for instance, like, yeah.
And maybe another component is, I think there are quite a lot of journalists out there being able to, let's say, use QGIS or other tools, other GIS tools. But I think it's not that common for them. Most of them more or less work with vector data, and less of them work with raster data. So I think there's a point to be made for making it really easy to download stuff like we saw earlier as GeoTIFF files in normal formats. That would be super helpful.
So a question here directly to Jonathan. So Jonathan, your visualizations from the earthquakes were really polished. Can you describe a bit the internal workflow to go that takes you from the ugly to nice?
Yeah. Well, I mean, in the case of the most complex visualization that I showed, which is the interferometry that Sentinel-1 completed. I mean, that's something that spans 3 or 4 days. So obviously you get the event. I think it was a Monday or a Tuesday. I can't remember. And so we started the discussion. Let's say it was a Monday. Okay. We started the discussion because I've worked with the group before on previous earthquakes, getting interferometric renders of events like that, volcanoes and earthquakes. So we have a discussion with them about when the best data is going to arrive. As I say, at the moment, Sentinel-1 is down to 1 satellite as opposed to 2, so you haven't got the repeat that you had. It needed to be in the right part of the sky to get that. We fixed out when that date was, and then literally as soon as that data comes down, we had a Zoom conversation about the best way to render that data. Now, you can do it in a number of different ways, and they had a quick go at producing the different ways of rendering that information. And then we had a chat about what we thought would work best for us. And then they go away, polish it. They give it to us in a form that we can manipulate, i.e. at a basic level is putting the cities on, right? Putting the scale bar on, putting the label on, putting the credit at the bottom to say where the data had come from. And in the 2-3 hours that is occurring, then I'm writing the story around it, explaining how satellite interferometry works and what we've learned from that particular event. So in that case, that's a beginning to end of about 3 or 4 days, but critically 1 day at the end of the week when finally it all comes together.
So leading on from that, and for all of you, which comes first, the story or the data? And I'm going to assume it's the story, but you're constrained by the data sources you have available. Gary, are you there and able to talk? I don't know if you are. Yes. So would you like to start off, and we can offer
Can you hear me?
Yes, please, Gary.
Yeah. Well, sometimes, of course, you got to work with the data you got, but sometimes I have the idea of a paper that I try to check. I try to check whether it's visible, whether it's workable or not. Sometimes it is, sometimes it's not. So yeah, it's both ways, I think. And sometimes I see data. For example, the Copernicus emergency service is open tweets about things that are inspiring. So you see things and you get the data after you see them and after you see them publicized. So I think it's both ways for me.
It works three ways, Mark. It works 3 ways. Sometimes you have the idea, and you approach the, either you go into something like Sentinel Hub and you have a look, see if you can pull something out, or you approach one of the companies and say, "Have you got anything going on this?" Sometimes, quite often, I will be, I'll see somebody's done something, made something. They've made an image. They've produced something. And then I'll write a story around that. And quite often what happens is that you're writing on a particular subject and the EO companies are watching what you're doing. They're reading what you're doing. And I mean, a good example, for example, is a big story was looking for the lost ship of Ernest Shackleton, the Antarctic explorer. Okay, so we're following this expedition in the Weddell Sea, trying to find this 100-year-old ship somewhere at the bottom of the ocean. Well, I'm here in the UK, and in California, Planet are going, well, Amos is writing about the Endurance. I'm sure we must be able to see the ship on the sea surface that's deploying these submersibles. And I open my email one morning, and they say, "Hey, Jonathan, we can see the ship that's looking for Shackleton. Do you want to use the image?" So it's, there's a conversation that goes around and around.
And I'm wondering if it's making a difference right now. The EO industry or marketplace, I guess, is maturing. It's becoming a more diverse place. There's a lot more companies. Is that affecting? Have you seen that as journalists? That change in the Earth observing industry world?
Yeah, completely. I mean, it's exploded in the last few years. So I mean, I get a lot of companies coming to me, with offers of imagery, and sometimes it's just, "Oh, that's interesting. I'll stick it on social media," or sometimes it's something that will fit into a story either that I'm writing, or that some of my colleagues may be working in that area and would find useful. But there's an awful lot out there, and as I said, some of them are really quite aggressive in trying to get their wares to you and to get them, to get you to use them. So yeah, I mean, and occasionally, they will play with you. They'll task something. You can have a conversation with some of these companies, and they'll see an opportunity for brand awareness. Clearly. So they'll if they're passing over, they'll take an image.
Moving on to a slightly different thing. So this is a question that struck me, but I'm not. We can probably play with the question a bit. Are there no journalists working in Africa, Asia, or Latin America who use data visualization from satellites? So in this workshop, we've taken the European perspective because we're coming from a Copernicus place. But of course, we're observing the whole Earth, and there are stories from everywhere. But there's an awful lot of capability to use this data in Europe. So would you mind talking about your relationship with journalists, science journalists or environmental journalists in other parts of the world, and what the disparity or biases in our storytelling may or may not be? Yeah, if any of you would like to start with that. I'm not sure of my question. You may be able to reframe my question because you probably thought about this more than I have. Anyone want to have a go? So Gary, Alex, or Jonathan? Oh, Achim, sorry.
Just going there. First of all, it's true that as a German news outlet, we focus mostly on German topics, and but over the last few years we had this internal project. It was called Global Society, which try to make stories or create stories for let's say the rest of the world, the underreported areas of the world, and there were lots of stories going on in Africa there as well. Frankly speaking, not a lot of them were Earth observatory based. Honestly, I'm not sure if a single one was, but the thing is that I think it would be helpful to use Earth observatory data. Not only if there's like a big catastrophe somewhere in a remote part or non-accessible part, as we saw earlier, but to maybe have a discussion about which positive effects could be shown, like reforestation, for example, or any positive change there, and to show that with observatory data, that would be interesting as well for us.
Gary or Jonathan, would you like to comment?
Well, in my case, it's a slightly unfair question, of course, because the BBC has language services. I can't remember how many we've got now. It's about 30. So, and we have a visualization unit that is working across all parts of the globe. So, if anything I produce, it goes into a central area. All of the files, are put in a folder that anybody then can extract and do anything with. So, I mean, we operate globally at the BBC. So there's an awful lot going on in the building in central London, which I don't see, that they'll only see in other parts of the world if they're reading those languages that we're rendering with, on the website. So it's the BBC is a bit of an unusual case there, I guess, because there aren't that many organizations in the world that operate on news organizations that operate in so many different languages.
Gary, thoughts?
As for Le Monde, we have people around the world, of course, covering the stories, the environmental stories around the world. There are actually, it's quite hard to work with them because they are. It's not very common for a decoder to work with the people that we got in the different countries, especially outside Europe, because we have actually. We are an online column. We don't work with the visual and graphic department who makes the print charts and maps. So we don't actually get to do international stories very often. We'd like to do some more from time to time, and I think we have to talk more with other departments inside the newsroom. But there is this is not something we do very often. So I guess this is the limits of boundaries inside the newsroom.
Okay, we're getting reasonably close to our time, but there's sort of a few questions left. So what I'd like to do is go around each of you, I guess, and let you answer the questions you would like to, and also leave us with a closing thought. Achim, Alexandra, if we start with you, so answer any of the questions you see before you, or any questions you think should have been asked that you would like to answer, and if you would like to leave us with a closing reflection, please do.
All right, we'll pick the one which is always very intriguing and interesting when it gets to the money. So where did it jump to? Exactly. For the journalists, are there any challenges to convincing your editors to invest the extra time resources to support stories with mapping? So actually, it's a very exciting topic for our editors and for all the departments. So there's a lot of investment actually happening in all those resources, lots of coding expertise that is coming to our places, and also lots of graphic expertise actually. So this is a growing market, I'd say, and we can also say if we measure how the people are consuming our stories, you can say that they're way more engaged when looking at those stories. They read it way longer, and they complete it way more often and to a higher percentage. So it's really worth investing in this sector, and that's also what our editors actually, they see this.
Yeah, maps work basically because you can transport so much information on a map. People can localize themselves on the map on maps. We have no problem, let's say, selling map-based stories to our editors, I would say.
Awesome. Thank you very much indeed. And thank you for your contribution today. Gary, any questions you would like to answer, or questions that aren't there that you would like to answer, or a closing thought or comment?
Yeah, I can answer the first one, the challenges for the editors. Sometimes, in my point of view, there are several challenges that can be met when you have to convince your editor to run a story, because maybe I actually am no expert in Earth observation. I actually work on it from time to time, but I have difficulties trying to see how all the tools works. So that last year, the piece I made on the Pakistan floods was very, very good, because Copernicus helped me, and they have lots of fantastic guys trying to help the journalist to meet with the technical stuff. That sometimes you have ideas of a story that you want to sell to your editor, but you don't even know if it's feasible, and you have to work your way around for like half a day, maybe a day or two, and that is time you don't actually get all the time. All the time, the news actually do pose a challenge, because you have to follow, and you actually convince your editor to take 1 day or two to see if it's feasible. Sometimes it's not as easy as it would, as I would actually like. So yeah, sometimes it's difficulty. It's difficult because I don't actually know by heart how to use perfectly the tools of EO to know that my story is solid and that I can get results. But yeah, I would like to know to work my way around more with the Sentinel data in order to be more solid and more experienced, because I think that's the first challenge that I made.
Awesome. Thank you very much indeed, Gary, and thank you for everything you've given us today. Jonathan, over to you.
Yeah, I was just looking at some of the questions here. Somebody's asking, are there data regarding soil moisture and soil temperature? Absolutely. The SMOS mission, fantastic mission that was launched by the European Space Agency. If you have a chat with the European Centre for Medium Range Weather Forecasting, they'll help you do that. I've done that with drought conditions in the United Kingdom, showing just just how little rain we've had some summers, and that's a great way to render that kind of information and to use it that way. Somebody's asking about social media and Twitter. Absolutely, get out there and start looking. You'll learn the accounts, right? I mean, you follow one account and you see that they're following another account, and you'll see the sorts of things that people are sharing, where they're getting the information from, who they're talking to. I noticed Hayley was asking about experts, saying, well, where do we get the experts from? Well, Hayley, we see people like you on social media, give the game away, right? The longer you kind of work in this little area, you start to learn about people who are doing this stuff. And the great thing about these seminars, if I can just give a plug for some of the people that are coming up in the next few sessions. A lot of these individuals do spend quite a bit of time sharing their work on social media. You'll see the sorts of things that they do, and they're very open. It's my experience. They're very open as well to talking about the work that they do, and be super helpful about pointing you in the right direction to get this sort of stuff. So yeah, I mean, get on social media and follow the EO influencers. Yeah.
Awesome. Thank you very much indeed. So we've come to the end of our time. This was our start of the whole journey. Quite often people are asking, will everything be made available? Yes. So we're going to make the recordings available. And also you'll start to see why we want the good practice guide, because there's a lot, particularly in what the journalists were talking about this afternoon, that we'd like to bring together so that people like me and others who are involved in Earth observing science I've got some clues as to how to help our stories be told in that wider community. I'd really like to thank all of the journalists for their participation. Really grateful to you. So thank you, Jonathan. Thank you, Gary. Thank you, Alexander and Achim. Unfortunately, Kasha had to go off on something else, so we lost her at the end, which is a shame because it would have been great to keep her perspective as well. But her thoughts will be in the Good Practice Guide. These seminars carry on and we get into the details now. So we start to look at atmosphere, ocean, climate, and right at the end in 5 weeks' time, we'll look more at the practical visualization. So thank you all, and thank you all for your contributions in the chat. And I hope you have a lovely day. Thank you all very much indeed.
Thank you very much. Thanks. Have a wonderful day.
Applause.
Yeah.